The ideas expressed in the following presentations are those of the speakers and do not necessarily reflect the views of ACI or its committees. ACI web sessions are recorded at ACI conventions or other concrete industry events and will be made available for viewing free of charge for 1 week. Thereafter, they will be archived on the ACI website or added to ACI's online CEU program, depending on their content.
I'm going to invite our first speaker is Dan Gancarz with Applied Research Associates. He's going to talk to us about implementation of performance specifications for concrete at the Illinois Tollway. Dan?
All right, thanks, Karthik. So before I get started, I wanted to acknowledge a couple people, Steve Gillen at the Illinois Tollway and Matt D'Ambrosio with CTL Group. They've been the main champions of getting performance specs implemented and developed for tollway application. Over the past couple of years, I've been leading the Tollway's review and approval process for concrete mix design, so I'm going to focus on my experience. So just to give you an overview of the Tollway system to set the stage for the implementation of performance specs, the Illinois Tollway is based in northeastern Illinois. Chicago is on the right there. So it's a 292-mile system comprised of 5 tollways. Opened in 1958 as a bypass around Chicago to connect Indiana and Wisconsin. We carry 1.6 million vehicles per day, and the important thing is we're a user fee system, so only customers who use the tollway pay for the tollway, and we receive no state or federal tax dollars for maintenance and operations. So the tollway is currently in the Move Illinois Capital Program. It's a 15-year, $12 billion program. 2017 is year 6. So far, we've completed the reconstruction of I-90, which is shown in red. That's 62 miles of complete reconstruction, including all mainline bridges and overhead bridges. And then we have other major projects such as the Elgin O'Hare Western Access, which is shown in blue. That's expanding the existing system and then extending it to O'Hare and creating a ring road around O'Hare on the west side. So now I'm going to talk about performance engineered mix designs, which it's commonly called now by AASHTO with the new spec coming out. So the Tollway's goals for performance mix designs: number one, we need strength. We want it to be adequate but not excessively over-designed. The big thing we're looking for is durability. So in northeastern Illinois, the main durability concerns are freeze-thaw and also chloride penetration resistance. And then we're also looking at shrinkage to mitigate cracking. And then we're also concerned about alkali-silica reaction. Other things we look at with our performance mix designs is constructability. We want them to be able to be batched accurately and consistently in the field so we get consistent performance. We also want them to be workable so that they can be adequately placed and finished in a timely fashion. And then finally, sustainability. The Tollway has a big emphasis on sustainability, so we're looking for ways to increase SCM usage and then also incorporate recycled materials when applicable. So here's a timeline of performance spec implementation at the Tollway. It started back in 2008 with accelerated weekend patching mixes. These are Portland-based systems that typically achieve 2,500 PSI in 16 to 24 hours. So not high early strength, but they are accelerated. And then as the Move Illinois Capital Program was getting underway, specs were developed for HPC mix designs used in bridge decks and approach slabs, and then also ternary black rock mixes for composite pavements. And when I refer to black rock, it is coarse, reclaimed asphalt pavement that is used as a replacement for a portion of the coarse aggregate, and it fits in more as a intermediate coarse aggregate. And then in 2013, we developed ternary optimized mixes for single lift pavements that were used on the eastern end of I-90. We also developed a performance spec for mass concrete. In 2014, developed a spec for calcium aluminate cement mixes, which is used for overnight patching, where we typically see 4,000 psi in 4 to 6 hours, depending on temperature and other factors. And then also on the eastern end of I-90, we implemented a performance-related construction specification for concrete pavement. So here's an overview of the Tollway mix performance requirements. All our mixes, we evaluate compressive strength. We look at flexural strength for pavements only, slump, plastic air, all mixes. And then we have our shrinkage testing. So we look at length change for all our mixes except pavement and calcium aluminate. We evaluate ring shrinkage on more of our high performance mixes, which is the high early strength patching, the HPC, and the calcium aluminate patching mix. We evaluate ASR on all mixes except the calcium aluminate mix. Similar hardened air, all mixes except calcium aluminate, and then chloride penetration resistance on, again, our more high performance mixes, the high early strength patching and the HPC. So here's an overview of the Tollway's mixture design and approval process. So we don't provide mix designs. We give the contractor, the supplier, the option. Well, we require them to design a mix. Certain mix types require lab trial batches for shrinkage, chloride penetration, other qualification testing, but we encourage lab trial batches for all mix types. And this is followed by a field trial batch, which we require on all mixes to verify that we are getting the performance that we're looking for. And then finally, all that's submitted to the Tollway for approval. So now I'm going to talk about a couple of our mix types that were used on I-90. So this is more of a close-up of the I-90 construction. The section there shown in purple and orange was built in 2013 and 2014, and that used primarily composite pavement. And on the bottom lift of that composite pavement was the ternary black rock mix design, which was a performance mix spec. And then to the east end of I-90, which is shown there in teal, we used a single lift concrete pavement, and that had a ternary optimized performance mix design spec, and then it also had a performance concrete pavement construction spec. So I'm going to talk about our high performance concrete for bridge decks. So our spec requirements, we have some proportioning requirements. So all materials have to be from an approved source. This is either primarily IDOT, the Illinois DOT approved materials, or for special materials, the Tollway has approved lists. We evaluate ASR at the proportioning stage. We limit the alkali loading from the Portland cement to less than 4 pounds. If the producer would like to go over that, we allow that, provided they perform ASR testing. For shrinkage mitigation, we have a option of doing 1.5 gallons of SRA per cubic yard and less than 605 pounds total cementitious, and that will waive the requirement for ring shrinkage. The producer's allowed to stray from that, but they have to perform the ring shrinkage test to prove that they are mitigating shrinkage concern. And then during production, we hold all of the Tollway mix designs to a water cement ratio tolerance. Basically, you can't exceed it, and you can go below it by only 0.03, because we want to minimize any potential effects from significantly dropping the water cement ratio. So some of the properties we evaluate for our HPC mixes, we're looking for 4,000 psi at 14 days. Plastic air, we allow a minimum of 4.0, and then the producer sets their design, and they're kept to a 1.5 tolerance. Slump is similar. The allowable range is 3 to 8, but they're held to a 1.5 inch tolerance during construction. We evaluate freeze-thaw or hardened air during the trial batch process. We evaluate slump loss during the trial batch process, and that's one of the tests we have to look at workability. It's one of the things we look at to prove that these mixes can be placed and finished in an ample amount of time. Linear shrinkage is done during the trial batch process, and then also chloride penetrability. So here's a mix design that was used on 22 bridge decks over the past 4 years on the Illinois Tollway. Now it's not required to be ternary, but the producer decided to take that approach. So we have 575 pounds total cementitious, water cement ratio of 0.4, which is not like a lot of HPC mix designs you may see. It's got a lower total cementitious, a higher water cement ratio. You don't see silica fume being used, but this mix meets the performance requirements that we're looking for as far as chloride penetration, shrinkage, and then strength. It uses 3 aggregates, so we got a coarse aggregate. It uses lightweight fine aggregate for internal curing to mitigate shrinkage. We have a natural sand, various admixtures, including a half gallon of SRA. So with this approach, they had to run ring shrinkage because they didn't want to use the 1.5 gallons and limit their cement content. So this was perfectly acceptable and met all the Tollway's requirements. And to our knowledge, there's no issues placing this mix. So moving on to our pavement mix, what we call our ternary optimized Class TL mix for pavements. We have some more proportioning requirements. So again, the materials have to be from approved IDOT or Tollway sources. The mix is required to be ternary with 35 to 50% SEMs. You're required to have an optimized gradation, which requires 2 coarse aggregates, and they must be virgin. And then we also have ASR requirement of less than 5 pounds per cubic yard on alkali loading. And then again, the water cement ratio tolerance during construction. So for our pavement mixes, what we're looking at is compressive strength. So we have a 3-day strength to get construction traffic on it at 2,500. Our design strength of 3,500 PSI at 14 days. And then we also have a 28-day target strength of 6,500 PSI. And this 6,500 PSI is used for the performance-related construction spec, and we selected it to be a little higher to accommodate the SEM usage. So we know it's high for a pavement application, but it's meant to accommodate the SEM usage. So we also evaluate flexural strength during the trial batch only, just to verify we're getting 650 at 14 days. We evaluate hardened air during the trial batch, evaluate spacing factor, specific surface, total air content greater than 4%. Plastic air is required to be between 5.5 and 8%. And then slump is the contractor's option. So they can place it whatever slump they need to get adequate consolidation. The only thing we evaluate is the slump edge after placement. So we're looking for a maximum of a 1/4 inch slump edge between adjacent lanes, and then if it's a free edge, we're fine with a 1/2 inch. So this is one of the mixes that was used on the I-90 construction. They placed about 25,000 cubic yards on one of the projects. It's about 40% SEM replacement, 505 pounds total cementitious, 4:2 water cement ratio, and then, as I mentioned, the 2 coarse aggregate requirement, and then your typical water reducer, air entrainment, retarder. And this mix was used for the performance-related construction specification, and it achieved over 100% for strength and air content, which I think is partly has to do with the producer's focus on quality control. They were focused on maintaining a consistent air loss between the plant and the job site, and then also monitoring aggregate moisture, making sure their process was consistent to achieve those requirements. So for our TL spec, we also have a combined gradation requirement. So the black lines are the requirement. The dotted green line was how this mix ended up, so pretty well graded. Also plotted this on the Tarantula Curve, which I think is part of the new ASHTO spec. So it falls well within the Tarantula Curve, also meets the requirements for fine sand and coarse sand, which is better than what we've seen in the past with a lot of our mixes that are gap graded or just not optimized properly. We'll commonly see a spike up around the half-inch sieve. So this mix, they really took the time to look at the overall grading and make it well graded with the materials they had. So summary and future changes. So in general, at the Tollway, we've seen from performance to prescriptive, reduced cement contents in both bridge deck mixes and our pavement mixes. We see increased SEM usage as part of having the requirement for the pavement mixes to be ternary. We've seen that other mixes are, although not required to be ternary, producers are selecting to make them ternary because they have the materials available. And now they're becoming more comfortable with higher replacement percentages. And then we also see a focus on durability, not just from the engineering side, but also from producers, contractors. There seems to be a more focus on quality control, consistency, and then also the things that affect chloride penetration resistance, shrinkage, workability. So some of the successes to date at the Tollway with performance specifications, we did about 200,000 cubic yards of the black rock mixes for composite pavements. That was in 2013, 2014. 2015 and 16 was the single lift ternary optimized, similar to the mix design I showed previously. That was approximately 500,000 cubic yards. Most were used for the performance related construction spec. And then HPC for bridge decks. Since 2013, we've placed over 100 bridge decks using the HPC spec. There's been no placement or finishing issues, and we've seen a significant reduction in early age cracking compared to the previous DOT mix that we were using in bridge decks. So some of our lessons learned, one of the key things is stakeholder buy-in. That is within an agency, making sure that everyone part of the project is on board with taking a performance approach, although it may not be the way things are commonly done, basically selling them on the benefits of performance and how it's going to improve the overall product, and then also getting the contractors and concrete producers involved, getting them the spec out in front of them, seeing if they have any concerns, and any issues with implementation. That was one of the things the Tollway did early on with such a large program, is they got this information out in front of the contractors so they had an idea what was coming, and we were able to address any of their concerns. One of the other things we've had to handle over the past couple of years is the request for material source changes. This was commonly done for Portland cement sources and fly ash and sometimes aggregate. So having an idea of what's going to be allowable and what's not, typically we'll evaluate how a source change will affect performance of that mix and then require appropriate testing. So for fly ash, that may involve a field trial batch and looking at hardened air, early strength development to verify that we're still getting the performance we intended to. And then constructability. The performance spec shifts more of the responsibility to the contractor, and this also places more risk on the contractor, but for innovative contractors and producers, it gives them the opportunity for greater reward, such as optimizing their mixes to reduce cost compared to the way they conventionally did it. So we're always looking to improve our specs, and some of the new performance measures we're evaluating include bulk resistivity for application of the formation factor. We're looking at this to replace the chloride penetration test and then looking at it as a general measure of durability. We're also looking at implementing the super air meter, possibly to replace current hardened air testing, and then also looking to replace plastic air testing with a super air meter requirement, which provides the total air and then your SAM number. We're also looking at the box or V Kelly test for workability during the trial batch stage. We're currently doing the box test on all pavement trial batches to evaluate the consolidation under vibration. And then as far as bridge decks, the main focus now, with help from CTL Group and Attorney Consulting Group, is looking at improving the service life of our decks. So right now we're evaluating using chloride penetration resistance or corrosion inhibitor to maintain our current crack resistance and then be able to achieve 50-year service life with epoxy-coated reinforcement. So this current work involves looking at our existing spec and our existing chloride loading rates on the tollway and determining what we're currently getting for service life and what changes we need to make to achieve that 50-year service life moving forward. So with that, I will take any questions.
How much crack reduction has been realized with all these changes? 3 parts to this question. Then, what is the cover in the bridge decks? And then 3, what do you do if you see a crack? What happens to the cracks?
So as far as the bridge decks go, we surveyed about 100 of the decks. I think this was earlier last year. And cracking is significantly down. There is still cracking in the decks, mainly due to restraint off the abutments, other factors other than shrinkage cracking. Our current cover requirement is 2 inches with a 1/4 inch tolerance. And then what was the last question?
What do you do to see a crack?
So currently, if the cracking's significant, we'll seal the deck. But honestly, over the past 4 years, it hasn't been a significant issue. It's been isolated cracking, and there's really been no need to apply a sealer or anything like that.